In the last lecture, we played around with our chart and we had this strange behavior that one column was getting bigger than the others because it had longer text in there, and that distorted our chart. And we could fix this with the flexible widget, but of course it's important to understand why we were able to fix it with that. For that, I prepared a very basic playground here. It's a simple app, and you of course find the code for that attached. It's a normal app as we created with Flutter Create, and I only changed the main Dart file to contain a row here as the body. I'm spacing my items with space around, so I'm aligning them on the main axis with space around. And then I have 3 containers in there. Each container has a height but no width, a different color on each container, and then we have some text in there. And the first container has a bigger text, which is why that box is, well, bigger than the other boxes. This is a comparable setup to what we had on the chart, right? We have 3 different elements in this case here, and one of them is getting bigger than the others. Now, first of all, it's important to realize that inside of a column or a row, every item is just as big as it needs to be or as you tell it to be. For example, on a container, we could also set a width of 300, and now we would have a way bigger container over there that even leads to that row not being wide enough to fit everything in there. So that's the first important takeaway. If you don't assign any widths and so on, then the items are as big as they need to be. Now, sometimes, however, you want to tell an item to take up more space in that row or column than it would normally take. And you can do that by wrapping it with a widget. Let's say we will wrap the second item, the second container here, with a new widget, and that is the flexible widget, which we used in the last lecture. Now there you learned that you can set a fit property. And now what does fit do, or the fit argument do? Fit takes a flex fit configuration. That's a enum with basically 2 values, loose and tight. The default is loose, so setting loose makes no difference here. What does loose mean? It means that the child of that flexible item basically should keep its size and use that size in the surrounding row or column. So as I said, it's the default and you rarely need to set loose explicitly. You would typically only set this if you kind of derive the value here dynamically, and you also sometimes switch it to its alternative, which would be tight. Now what does tight do? If I wrap my item 2 here with flexible fit set to flex fit tight, then you see all of a sudden this blue container takes up all the remaining space here in our row. Please note that it only takes as much space as fits in there without squeezing any items off the screen, which is why we're not getting this yellow-black warning marker here. So now blue essentially knows, okay, I should take all the space I can get. And indeed, if you have a look at the description of tight, then this is forced to fill the available space. Loose doesn't force the child to fill the available space, and therefore it will fill the space it needs to fit its content in, which in this case is only this text here, or if we had set a width on the container, it would be the width we set here. But now even when we set a width of, let's say, 100 here, with flex fit tight, this is basically ignored, and it is forced to take all the available remaining space here. Now you can also do other cool things. Let's say we also have the third container wrapped with that. So I wrap this with a widget 2, give it a flexible widget around it, and set fit to flex fit tight. So to the exact same configuration as my item 2. Now you see the 2 items here split the available space. And now if I remove that extra text on the red element, on the first element, you see that this now gets squeezed to only have the bare minimum of space it needs to fit its text in there, which would be the default space it takes because we have no flexible widget around the first container with flex fit tight. We have no such setup there. And therefore, this only takes the space it needs. The other 2 widgets, the other 2 containers, however, are configured to fill the available remaining space. And that means right now, since there are 2 containers, which each want to take the available remaining space, they split the remaining space amongst them. Now, sometimes you want to have that behavior of taking the available space, but you also know, yeah, both should take the available space, but the blue container should get twice as much of that available space as the orange one. And for that, you can add another argument here on the blue container then, and that's the flex argument, which I only explained in theory in the last lecture. Flex by default is set to 1 on every element, so setting this to 1 won't make a difference. However, watch what happens if I set flex to 2 here. If I do set this to 2, now you see the blue container grew. And now, if that here, the blue and orange area together, is our remaining free space after deducting the red container from the full row, then you see that blue is now twice as big as orange, because we gave it a flex value of 2. Now, important, 2 does not mean twice as big as the rest. Instead, this works a bit like Flexbox for the web, if you know that from CSS. If not, that's no problem. Flutter goes ahead and basically adds the flex values of all items in the row, which means the first item here has no flex value because it's not wrapped and flexible, but then we have a flex value of 1 here, which is the default for our third container. So we have flex 2 plus flex 1, which means we have a total sum of 3. Then Flutter knows that since this here has a flex value of 2, it wants to take 2 of 3 available segments, and this one has the default value of 1, it takes 1 of the 3 available segments. So this takes 1/3 of the available size, this takes 2/3. If we, for example, added flex 2 on the last container as well, they would split the size equally again. Why? Because we have a total flex value of 4, 2 plus 2, and Flutter now finds out that the middle container wants to take 2 segments of these 4 available segments to split the available space, and the last container wants to take the other 2 available segments. So therefore now they're evenly split. So these flex values have to be seen in relation to each other. If we have 5 and 2 here, this means, well, this is 5 to 2 in terms of how much space it takes. We have a total of 7 segments into which the available remaining space is split up, and this container here takes 5 of these 7 segments, this one 2 of these segments. So this is 2.5 times as big as the last container. This is how you can play around with that, and that's of course super useful for sizing your elements in a row or column. Now, back to the fit here now. If I change the item free to a flex fit of loose, you now see the container itself now only takes as much space as it needs for its child. And yet we see that there now is some empty space, some white space. The reason for that is that the flex values here are actually still taken into account. If I set the last item here back to flex 1, you see now there's less available free space. The reason for that is that we still have flex fit tight on the blue container, which means take all the space you can get, but we at the same time tell it, but you only get 5/6, because 5 plus 1, 5/6 of the available space. So even if the last item doesn't fully occupy the remaining available space, so the 1/6 that it could take, even if that's not the case, this middle container is still configured to only get 5/6 of the available space. And that means that 1/6, which the last item could take if it would be set to tight, that is simply left open, which is why we have white space all over our row, because that white space together would add up to the size the last box could take if it would be set to flex fit tight, which it isn't, therefore it only takes the space it needs for its content, and the space it could take is left empty. And because we have our alignment set to space around, that empty available space, which is not taken, is, well, split across the entire row and not just somewhere here at the end. So I hope this makes a bit of sense. As always, playing around with that, building a demo app like this and simply trying out different configurations is the best way to dive into this and to really master it and get a feeling for this. That's way better than learning all these different rules and combinations by heart. You won't be able to remember all of that, and also there is no value in doing so. Instead, build a simple application like this and play around with these settings to get a feeling for how FlexFit tight and flex fit loose and the different flex values work together. One last word. If you have flexible with fit set to flex fit tight, there also is another widget which you could use, which is a replacement for it. There is the expanded widget in Flutter. Expanded is simply flexible with flex fit tight, and therefore expanded has no fit argument. You can't set it here. Instead, expanded only knows the flex configuration here, which we used on flexible. So expanded is a perfect replacement for flexible with fit set to flex fit tight, and therefore if I save this, you see no difference on the screen because it is the exact same. So if you need flex fit tight, instead of using flexible with that configuration, you could simply use expanded instead. And that's it for now with rows and columns and flex and flexible and how to size the items in there. Again, definitely fire up your own demo app and play around with these values to get a better feeling for how this all behaves and how you can distribute available space in your rows and columns.